Hello, everyone. I'd like to welcome Dr. Vikram Saksena, who is the Chief Solutions Architecture for NETSCOUT Strategy and Solutions Architecture Initiatives. He's in the CTO office at NETSCOUT, working with Tier 1 carriers and helping them strategize on their next generation 5G strategies as they pertain to cloud native, edge computing, etc. So welcome, Vikram.
Thank you, Jennifer. Thank you. Thanks for having me. I'm happy to be here.
I'm happy to be talking with you today. For those of you who do not know me, I'm Jennifer Clark. I'm with Heavy Reading as a principal analyst, specializing in the edge and cloud native uh, lines of business. And today we are going to be talking about cloud native, the whys, the whens, the wherefores, and I'm looking forward to hearing your insights, Vikram, into this transformation journey to cloud native. So
Yeah,
let's
absolutely. Yeah. Thank you.
Great. So let's dive right in. Um, why is the industry going to cloud native?
So, let's focus on our networking industry because, a few years ago, when the journey started from a hardware-centric world to a software-centric world, we used to use a term called virtualization or network function virtualization, right? And the idea at that time was to use the concept from data centers on creating virtual machines and putting network functions in virtual machines. And what we have learned over the last maybe 4 to 5 years is that although that concept has certain benefits, but there are also some significant drawbacks when it comes to networking. For a data center, I think it works fine, but from a networking perspective, there are a lot of nuances which are different than running applications in a data center, specifically when it comes to agility, elasticity, automation, because things change very rapidly in the network. So I think people realized from that idea that we needed something which had more flexibility and more adaptability to the way the network demands keep changing. So the advantage of cloud native, I would say, are in three specific categories compared to virtual machines. One is agility, elasticity, and automation. Agility is all about service innovation, being able to change things on the fly rapidly in response to customer needs and so on. And fundamentally, in the cloud native architecture, it's a service oriented architecture. It's based on open APIs. It uses service discovery and things like that, which were not there in the right shape in the NFV world. So what it allows operators to do is be very nimble and be very agile in reacting in near real time to customer demand. So that's one aspect. The second one is around elasticity, which means being able to scale up and down, auto scaling, sometimes that term is used, that when your network demands are constantly changing, you need to be scale up and you also need to be scaled down. Specifically in 5G, when you're talking about edge cloud, small data centers at the periphery of the network, which don't have many resources, you need to be able to scale things down. And in that model, the virtual machines can be very inefficient because of the overhead involved in each virtual machine. So the idea of using containers and microservices where you can cut things down to small footprints to fit in the edge is extremely important. So elasticity is much better in a cloud native environment, especially when you're talking about a distributed architecture like 5G. The third one is around automation. When you want to be able to provision and scale and change things on not just 0 day, but on an ongoing life cycle basis, then you need a fully automated environment to control your hundreds of edge clouds, your core clouds, and what's happening with your control plane and user plane. So one thing with cloud native, because Kubernetes was built in from day one into the way you manage containers and microservices, gave a leg up on automation. Everything is programmable in this world, or the orchestration policy functions, they're all programmable. And so you get a lot of benefits from automation from get-go in a cloud native world, which you had to overlay in a virtual machine. OpenStack came and added things, and Mano and whole bunch of technologies came later, but it was not the same as building it in from day one. So I would say those are the three main benefits. And one last point, in terms of 5G, I think it's even more important because when you want to do things like network scaling, control and user plane separation, cloud native and microservices work much better.
Absolutely. So, if with 5G, carriers are going to be multiplying the number of base stations by a factor of 3 or 5 or 7 in the not too distant future, the ability to be flexible, to scale effectively, and to be automated certainly are crucial to that. So, tell me, given that, why is cloud native important for NetScout? What does NetScout bring to this cloud native integration?
Yeah, so let's see what cloud native is first doing for the operators, and then we can talk about how we play in. Cloud native for operators, for me, is important because it expands their addressable market. They have been primarily a consumer serving company from I'm talking from a mobile point of view, 4G and prior generations of technology. With 5G, with a broader range of frequencies now, millimeter wave, mid-band, and so on, the focus is shifting towards embracing enterprise customers, specifically, what the industry uses a term called Industry 4.0 applications, which is all around factory automation, transportation services, e-health services, and so on. So in this world, when you're going after enterprise services and enterprise applications where a lot of these things have zero tolerance for defects. If you're doing a remote surgery, if you are have failure in a factory, which impacts your production and delays and revenue, if you have accidents on the road. So a lot of these applications are mission critical, life critical, business critical, and they have zero tolerance for defects. So in that sense, I think what we need to understand is the game on service assurance and security assurance has to be elevated. The way we used to deal with service assurance in 4G was to deal with systemic problems. Transient failures, people could work around it. If you have a poor connection, you move to a better place. If you had a dropped call, you dial again and you would get through. If you have a slow download on your web page, you can move to a better coverage and you get a faster download. So humans know how to work around transient issues in the network. But these devices and sensors that are being connected to the network, they don't have any ability to do that. So your network has to be what I call, zero defect, or
Hmm.
zero defect. So service assurance has to be more predictive, and the actions have to be more proactive. So you can avoid defects rather than reacting to defects to fix them, because a few seconds of defect could have a big impact on businesses and enterprises which are being connected. So that's where I think the role of NetScout becomes very critical, because we are probably the only or one of the few companies which focus on the service layer of the of the network as opposed to infrastructure. There are many telemetry solutions which focus on infrastructure metrics, infrastructure performance, the network element performance, radio performance, core performance. We focus on the service layer, which includes the control plane and the user plane. And when you're talking about both of these layers, when you're talking about, let's say, low latency applications, you need to be able to measure latency at the application layer. If something requires sub 10 millisecond latency, you're not going to get that from infrastructure telemetry. So we go directly by looking at network traffic. We look at those metrics directly and able to then predict based on our sophisticated AI ML algorithms to be then able to alert or send notifications to your closed loop automation platform so they can take corrective action before you see a failure impact an end customer. So I think our role becomes elevated in 5G compared to 4G because the applications are more critical from the point of view of service assurance. So I think that's why we feel pretty excited about the future that's coming to us. So.
Great. Thank you very much for those insights. And I totally agree. As the 5G network scales by many orders of magnitude, as we expect it to, you cannot rely on reactive analytics. They have to be predictive in order to keep your services and the network up. So thank you very much for this discussion, Dr. Vikram. And we will look forward to our next conversation.
All right. Thanks, Jennifer. Really appreciated the dialogue. So thank you so much.